Hello and welcome to the HydroDock Rotary Distributor Compressed Air System, which consists of an air compressor and an air dryer used to supply air to the HydroDock Rotary Distributor. My name is Kevin Ball and I will be narrating this presentation. WesTech Engineering, the supplier of the HydroDock Rotary Distributors and the air compressed system, is located in Salt Lake City, Utah. Presentation overview. For the air compressor equipment, we will go over the following: the components that make up the air compressor, the operation of it, maintenance, safety precautions when working on the air compressor. For the compressed air dryer, we will go over components, the operation of it, maintenance, safety precautions, and at the end, the procedure for ordering spare or replacement parts. The electric drive air compressor consists of the following components. It is a Gardner Denver model VR5-12. It has a 120-gallon air receiver tank, which this is this component here. It has a 5-horsepower motor right here. Proper rotation of the motor is important. The compressor is meant to run in a clockwise rotation. And on the motor, there is a sticker, a directional arrow, so it needs to be confirmed that the compressor rotates clockwise fashion. It is an R15 compressor. It has an inlet filter, which is located right here. So the basis of the compressor is air enters into the compressor. This is a two-stage compressor, so it goes through the first stage, then goes to the second stage, leaves the compressor, goes through an aftercooler to cool the compressed air down, enters the receiver tank here, and on the opposite side, which can't be seen, air exits the compressor and comes over to an air dryer sitting adjacent to the compressor. It has a control panel, which is located right here. On the control panel, there is an hour meter, a switch, which is test off auto. It also has indicating lights for overtemp, which is related to the air temperature. It also has a motor overload. If the motor is heating up and it goes beyond its rated thermal capacity, it'll shut down and show indication here. And it's also got a low oil monitor. If the oil in the compressor goes too low, it'll show indication on the control panel here. It has an automatic electric tank drain for moisture. The drain is at the bottom of the receiver tank, but the controls for it are right here. So when the automatic drain works, it takes the moisture, flows up this tube and exits through an exhaust up here in this location. It has an air pressure switch, which is located right here, which runs the compressor, turning it on and off at preset limits. It has a low oil level monitor, which is located back here on the side of the crankcase of the compressor. It has an hour meter, which is on the front of the control panel, which is useful for maintenance. It has a high temperature switch, as mentioned, which is located right here. It measures the air temperature as it's exiting the compressor. As mentioned, it has a motor overload, so if the motor overheats, it'll shut down. It has an air-cooled aftercooler, which is located back here. So as the air exits the compressor, it goes through the aftercooler to reduce the temperature to approximately 100 degrees or less when it goes into the receiver tank. As mentioned, it's got the test off auto switch, normal operation. The switch will be an auto. Operation of the air compressor. It is designed for 80% on, 20% off duty cycle. The pressure switch senses changes in the receiver pressure. So the pressure switch is located right here. It automatically starts and stops the compressor at preset pressure limits. When the air receiver pressure reaches the cutout setting of the pressure switch, the compressor will stop. When the air receiver pressure drops to the cut-in setting of the pressure switch, the compressor will start. At the factory, the cutout pressure was set at 125 psi and the cut-in pressure at 95 psi. During startup, that was changed to the cutout pressure at 100 psi and the cut-in pressure at 70 psi. The compressor is supplied with an auto drain. It automatically drains moisture from the receiver tank. The amount of time the drain stays on is user adjustable between half a second to 10 seconds and is adjusted using this dial right here. The amount of time between each drain cycle is user adjustable between half a minute to 45 minutes and is adjusted using this dial right here. The air compressor is supplied with an oil monitor, which is installed on the outside of the air compressor crankcase. It has a port that allows oil to feed into its float bowl chamber and maintains the same level as the crankcase. The float moves up or down as the oil level changes. If the oil level is below the minimum allowable operating level, the reed switch will open, stopping the motor. If it experiences a low oil level, in order to start the compressor, the following steps must be taken. Fill the crankcase to the recommended capacity as indicated when the level reaches the middle of the oil sight glass. Then there is a reset knob that must be turned 90 degrees clockwise to reset it. Maintenance. The compressor requires oil lubrication. Use ISO 100 non-detergent industrial oil with rust and oxidation inhibitors, specially formulated for reciprocating compressors. It is recommended that only EON reciprocating lubricant be used. Do not mix oil types, weights, or brands. Volume of oil is approximately 2 quarts. Compressor was shipped with EON AC HC mineral oil. Maintain lubricant level at the center of the sight glass when the compressor is idle. Oil fill is located here. Oil drain here. Sight glass is here. Maintenance continued. The compressor break-in period is 100 hours of operation. Compressor must run for the break-in period using EON ISO 100 lubricant. During the break-in period, a careful and regular check of oil level should be made. Maintain oil at the full line. After the break-in period, thoroughly drain existing oil from crankcase. Add a full charge of EON ISO lubricant. The compressor was shipped with EON AC HC mineral oil. Change oil every 500 hours if using EON AC HC mineral oil. After draining and refilling the compressor crankcase with the recommended capacity of oil as indicated when the level reaches the middle of the oil sight glass. The cam reset knob on the oil monitor must be rotated 90 degrees clockwise. If changing to a synthetic lubricant, the following steps must be completed. The compressor must run for the break-in period of 100 hours using EON ISO 100 lubricant. During the break-in period, a careful and regular check of the oil level should be made. Maintain oil at the full line. After the break-in period, thoroughly drain existing oil from the crankcase. Add a full charge of EON ISO 100 synthetic lubricant. Run the compressor for 200 hours. Stop compressor and thoroughly drain the synthetic lubricant. Add a full charge of EON ISO 100 synthetic lubricant. The compressor is now ready to run for an extended period before the next lubricant change. And please note, remember to reset the knob on the oil level monitor 90 degrees clockwise. EON AC lubricating oil. These are the only factory tested, approved, and recommended lubricants for Gardner Denver reciprocating compressors. On the left is the specifics or some of the advantages of a mineral oil. On the right is the advantages for a synthetic. The major difference is mineral oils are less expensive, but the service intervals are much shorter, whereas synthetic oils are much more expensive, but your service intervals can be extended. The motor requires grease lubrication. Long life and satisfactory operation of an electric motor depends on large measure on proper lubrication of the bearings. The recommended grease is Mobile Polyrex EM. The relubrication interval for motor bearings is 1200 hours. The amount of grease to add to each bearing is 0.19 ounces or 5 grams. And here on the right are the grease zerks for the motor. There's 2 locations as depicted. Monthly maintenance. Remove and clean intake air filter. Clean dust and foreign matter from cylinder heads, motor, fan blades, air lines, intercooler, and tank. Check V-belts for proper alignment and tightness. Proper belt tension needs to be maintained. Belt tension can be checked using a belt tension checker tool. WesTech has supplied a belt tension checker tool to check the belt tension on each compressor. Measure the belt span. On the belt tension checker, position the O-ring on the span scale at the measured belt span. Position the O-ring on the deflection force scale to 0. Place a straight edge across the outside diameters of the motor pulley and compressor flywheel. Place the tension checker squarely on one belt at the center of the belt span. Apply a force on the plunger perpendicular to the belt span until the bottom of the large O-ring is even with the bottom of the straight edge. Remove the tension checker and read the force applied from the bottom of the small O-ring on the deflection force scale. Compare the force you have applied with the values given in the table in the chart below. The force should be between the minimum used belt and maximum new belt shown. Make adjustments to the location of the motor to achieve proper tension. This chart shows the belt deflection force based upon the model, which is the R15, 5 horsepower. So with a used belt, the deflection force should be 3.1 pounds minimum, and a new belt, 4.4 pounds max. The values given in the belt deflection force table are calculated for nominal conditions and are provided for reference only. The required tension may vary due to application, manufacturing variances, component wear, etc. Dry belts must be kept tight enough to prevent slipping. If belts slip or squeak, they need to be tightened. Caution: if belts are too tight, overload will be put on motor and motor bearings. Belt cross-section can be found printed on the outside surface of the belt. Safety precautions. Read all instructions completely before operating air compressor unit. Do not attempt to service any part while compressor is in an operational mode. Lock out or tag out all power sources before attempting to work or perform maintenance on the air compressor unit. Do not attempt to remove any compressor parts without first relieving the entire system of pressure. Do not use flammable solvents for cleaning the air inlet filter or element and other parts. Do not operate the compressor without guards, shields, and screens in place. Be careful when touching the exterior of a recently run motor. It may be hot enough to be painful or cause injury. Do not operate the compressor at pressures in excess of its rating. Be sure no tools, rags, or loose parts are left on the compressor or drive parts. Components of the compressed air dryer. Gardner Denver model GHLD-25. It has a sequence controller, 2 dryer towers, a coalescing pre-filtration with auto drain, a control air filter, a particulate filter, a bypass system, pneumatic valves, and purge exhaust piping. Sequence controller. Sequence controller is a logic system that controls the drying time for each tower, set at 5 minutes, and the purge time for each tower, which is set at 4 minutes and 30 seconds. These time cycles are factory set and should not be adjusted. Dryer towers. These contain a desiccant for removal of water vapor. Pre-filtration. Coalescing pre-filtration with auto drain. This eliminates carryover droplets from the compressor. Any aerosols, compressor lubricant, liquids, adds life to the desiccant by preventing fouling caused by compressor lubricants. This is the filter here. From the compressor, air enters into the dryer at this connection point right here. Control air with filter. Control air is used to operate the pneumatic valves at the base of the air dryer. Control air filter is required so desiccant particulate does not restrict the control air required for pneumatic actuation of the dryer valves. The particulate filter. Regenerative desiccant dryers gradually produce hard and abrasive desiccant fines. Fines are removed by the particulate filter. Material collected is held in the bottom of the housing. Simply clean out the sump area as an element is replaced. The bypass system. This facilitates servicing the dryer and filters without interrupting compressed air flow. Bypass the system by closing the upper and lower ball valves and opening the middle ball valve. Operation in this condition for extended periods of time is not recommended. Possible contamination from desiccant dust, moisture, or oil. Pneumatic valves. These valves direct airflow for drying of the process air and the purge exhaust stream for regeneration. Valve operation of opening and closing is by the sequencing controller. Purge exhaust piping. Purge stream air exits to atmosphere through the purge exhaust valve and muffler. This process is maintained for 4 minutes and 30 seconds. At the end of this time period, the purge valve closes and allows the purge stream to repressurize the regenerated tower, preparing it for the next cycle of adsorption. Operation of the compressed air dryer. Fully automated with the sequence controller. Time cycles are factory set and should not be field adjusted. Air from the compressor enters the dryer through a coalescing pre-filter. Compressed air enters either the right or left tower depending on the control sequence position. In this illustration, the right side is drying the air and the left side is regenerating. Compressed air passing through the right tower gives up all of its water vapor to the desiccant. This cycle will continue for 5 minutes. While one tower is drying the process air, the other tower is in the regeneration mode. The regeneration is accomplished by utilizing a regulated portion of dry compressed air called the purge stream. The stream is expanded to near atmospheric pressure by passing through an orifice. This dry air is passed over the saturated desiccant bed to absorb and carry away moisture. Saturated purge stream exits through the left tower purge exhaust valve and muffler. The regeneration process is maintained for 4 minutes and 30 seconds. At the end of this time period, the purge valve closes and allows the purge stream to repressurize the regenerated tower. At 5 minutes, the sequence controller switches the valves, and the left tower now receives air from the compressor, and the process repeats in reverse. Purge air pressure should be set to 40 psi. This is set by adjusting the needle valve downstream from the air control filter. Maintenance. Pre and after filtration, elements should be replaced on an annual or biannual schedule based on system contaminant load. The control air filter is generally replaced when the after filter on the dryer is replaced. Purge muffler. If the purge tower shows back pressure during operation, replace the muffler element. Desiccant life is estimated at 3 to 5 years. Spent desiccant is drained through a drain port in the bottom of each tank. Desiccant is loaded by removing the pressure safety relief valves. So at the bottom of each tank is a port that can be removed to drain the desiccant, and at the top of each tank is a pressure relief valve. These pressure relief valves will need to be removed, desiccant added, and then the pressure relief valves reinstalled. Safety precautions. Read all instructions completely before operating compressed air dryer. Compressed air is a highly hazardous energy source. Depressurize the system prior to performing any work or maintenance on that system. Never work on equipment with parts under pressure. Lock out or tag out all power sources before attempting to work or perform maintenance on the air dryer unit. Do not attempt to remove any air dryer parts without first relieving the entire system of pressure. Procedure for ordering spare or replacement parts. Spare or replacement parts may be ordered from the aftermarket sales department at the following email address, parts@westechwater.com, or by phone at 801-265-1000. Should you require further assistance in determining which spare parts are appropriate for your particular situation, please contact WesTech's Aftermarket Sales Department. Identify equipment using the WesTech job number. Your equipment is identified as follows. WesTech job number 24416A, WesTech model number RDS13S, equipment type 6 Hydrodrock rotary distributors with compressed air system. Refer to the O&M manual for more in-depth information on the compressed air system.